Hi there, may the peace and blessing of Allah be upon you all. This is the final part of the first lesson, quadratic equation, or how to solve the quadratic equation, but today by graphing. So today we'll graph the quadratic equation and then identify the roots of the equation. So stick around and keep watching. To graph a function, and this is the third part of the lesson. To graph a function, we have some steps. The first step is getting the equation in the standard form. You remember the standard form, ax squared plus bx plus c is equal to 0. The most important thing is equal to 0. So if it's not equal to 0, make that equal to 0. And then the next step is naming the left-hand side f of x. So f of x is equal to ax squared plus bx plus c without equal to 0. It's just the left-hand side. And then it's time for the third step, which is making a table. Now you have two rows, the first row for x and the second row for y, which is f of x, which is the value when you are substituting x with the number or the value and the function, you get an answer. That answer is y. All right. So how can you get the numbers to put in the table or in the x-axis? Now we have two cases. Maybe you have an interval, if the interval is written in the example. So put the numbers of the interval ascendingly or descendingly in the x row. For example, if you have the interval -2 and 2. So x is equal to -2, -1, 0, 1, and 2, and so on. But what if you don't know the interval or the interval is not written? That means you want to guess the numbers. But guessing the numbers will take a lot of time. So it's just focusing on the vertex. What is the vertex? Just get the vertex and put it in the middle. The vertex is x is equal to -b over 2a. That is the formula of getting the vertex. And you remember the quadratic formula, which is -b plus or minus the square root of b squared minus 4ac all over 2a. This is the first part of the quadratic formula, -b over 2a. This is for getting the vertex. All right, so getting the vertex and put it in the middle of the x row and then complete the table and then get y. And I will show you how that works in the next examples. But now it's just a summary. When you draw, this is step number 4, draw a table, draw a function by graphing. Maybe the graph is like this, or like this, or like this. So now if you graph the function, how do you know the roots, or how do you know the solutions? Yeah, the solutions are just the numbers of x-axis that the curve intersects x-axis. For example, here in this example, the curve intersects x-axis in or at 2 points at most. So the first point, which is m, I'm just focusing on x values, m and n. All right. So here the solution set is m and n. But what if the curve is just touching the x-axis at 1 point, like at x is equal to m, for example? So the solution set is equal to m. And what if the curve doesn't touch or doesn't intersect x-axis at all? So there is no solution. So the solution set is equal to phi. And maybe the curve is going up or going down. It's just a note here. If a is greater than 0, a is the coefficient of x squared. If a is greater than 0, like 1, 2, 3, 4, if a is positive, so the curve will going up. And if a is negative, so the curve is going down. In this example, solve graphically in R, x squared minus 4x plus 4 is equal to 0, taking x belongs to the closed interval 0 and 4. All right, let's revise the steps that we mentioned before. The first step is making the equation in the standard form. Is it in the standard form? Yeah, so it's already in the standard form. So moving on to the next step, which is calling or naming the left expression f of x. So f of x is equal to the left-hand side of the equation, which is x squared minus 4x plus 4, without getting 0, without equal to 0. All right. So now we are ready for the third step, which is drawing a table, the first row for x and the second row for y. And do you know the interval? Yeah, of course, the interval is written in the example from 0 to 4. So start with 0 till you reach 4. So 0, 1, 2, 3, 4. And each time you will substitute x with each number and then get y. So f of 0, substitute x with 0, 0 squared minus 4 times 0 plus 4, which is equal to 4. So f of 0 is equal to 4. And then substitute x with 1. So f of 1 is equal to 1 squared minus 4 times 1 plus 4 is equal to 1. And negative 4 times 1 is negative 4. And then plus 4, which is equal to 1. So f of 1 is equal to 1. Now it's time for 2. F of 2 is equal to 2 squared minus 4 times 2 plus 4. 2 squared is 4. And negative 4 times 2 is negative 8. And then plus 4 is equal to 0. So f of 2 is equal to 0. Now f of 3 is equal to 3 squared minus 4 times 3 plus 4. 3 squared is 9. And negative 4 times 3 is negative 12. Plus 4, which is equal to 1. So f of 3 is equal to 1. And then finally, we have 4. Substituting x with 4. So f of 4 is equal to 4 squared minus 4 times 4 plus 4, which is 4 squared is 16. And negative 4 times 4 is negative 16. And then plus 4. So it's equal to 4. So f of 4 is equal to 4. Now we can graph the function. The first point is 0 and 4 is here, and 1 and 1, and then 2 and 0, and then 3 and 1, and then 4 and 4, and then connect between the points. Now the question is, where the curve intersect, or where the curve does intersect x-axis or touch x-axis. Of course, it's intersecting x-axis at one point, which is 2 and 0, but we are just focusing on the x values. So x is equal to 2 is the solution of the curve, or the solution of the equation. So the solution set is equal to 2. Find in R the solution set of the equation f of x is equal to 0. And now you have the graph ready for each one. The first graph on the left, the graph number 1, you know that the curve is touching the x-axis at just one point. So the solution set is equal to just one value, which is x is equal to negative 2. And in the next one, as long as the curve doesn't touch the x-axis, so there is no solution. The solution set is equal to phi. And in the third one, you know that the solution set is 2 values because the curve intersects the x-axis at 2 points. So the values of x is negative 3 and 1. So the solution set is equal to negative 3 and 1. Solve graphically in R. Negative 2x squared minus 4x is equal to negative 1. Let's move on to the first step, which is the standard form. Is it in the standard form? Nope, it's not in the standard form. The standard form should be equal to 0, and you don't have equal to 0 here. So moving negative 1 to the other side in the opposite sign, it will be positive 1. So negative 2x squared minus 4x plus 1 is equal to 0. Now it's in the standard form. So f of x, which is step number 2, f of x is equal to negative 2x squared minus 4x plus 1. But here when we draw a table, we have the first row for x and the second row for y. But as you see here, the interval is not mentioned. So what is the solution? How can we get the numbers? How can we write down the numbers in x-axis or in the x row? You remember? Yeah, x is equal to negative b over 2a is the formula of the vertex. It's just to put the number in the middle of x row and then complete the table. So x is equal to negative b over 2a. A is equal to the coefficient of x squared, which is negative 2, and b is equal to the coefficient of x, which is negative 4, and c is the constant term, but we don't need it, which is 1. All right, so x is equal to negative b over 2a, negative b, which is negative times negative 4, divided by 2a, which is 2 times negative 2. So it's equal to 4 divided by negative 4, which is negative 1. So the vertex x is equal to negative 1. All right, so put negative 1 in the middle and take 2 values on the right and 2 values on the left. Before negative 1, here there's negative 2, and here there's negative 3. And on the right, you have 0 to the right of negative 1, and also 1 to the right of 0. All right, now substituting x with all of these values and the function, we get f of negative 3. We will start with negative 3. F of negative 3 is equal to negative times negative 3 squared minus 4 times negative 3 plus 1, which is negative 2 times 9. Negative 4 times negative 3 is 12, and then plus 1. So it's equal to negative 18 plus 12 plus 1, which is negative 5. So f of negative 3 is negative 5. F of negative 2 is equal to negative 2 times negative 2 squared minus 4 times negative 2 plus 1. So it's equal to negative 2 times 4 plus 8 plus 1 is equal to negative 4. Negative 2 times 4 is negative 8. So negative 8 plus 8 plus 1, which is 1. So f of negative 2 is 1. All right. So f of negative 1 is equal to negative 2 times negative 1 squared minus 4 times negative 1 plus 1, which is negative 2, because negative 1 squared is 1. So negative 2 plus 4 plus 1, which is 3. So f of negative 1 is equal to 3. All right. So f of 0 is negative 2 times 0 squared minus 4 times 0 plus 1, which is 0 minus 0 plus 1. So f of 0 is equal to 1. All right. Now the last value, f of 1, is equal to negative 2 times 1 squared minus 4 times 1 plus 1, which is negative 2 times 1 minus 4 plus 1 is equal to negative 2 times 1 is negative 2, and then minus 4 plus 1 is equal to negative 5. And then you can graph the function negative 3 and negative 5, negative 2 and 1, negative 1 and 3, 0 and 1, and then 1 and negative 5. So you see here the curve intersects x-axis at 2 points. So the values of x of these 2 points is negative 2.2 and 0.2, as you see here in the graph. So the solution set is equal to negative 2.2 and 0.2. The opposite figure represents the curve y is equal to ax squared plus bx plus c. Which of the following is true? And we have multiple choices here. A is greater than 0, c is greater than 0, a is greater than 0, c is smaller than 0, a is smaller than 0, c is greater than 0, a is smaller than 0, c is smaller than 0. If you remember, we mentioned that a is the coefficient of x squared, and you see that if a is positive, so the curve is going up. But here the curve is going down. That means a is negative. So we have a is smaller than 0. So we have two choices right now so far, C or D, because here a is smaller than 0, and also here a is smaller than 0. But what about C? Yeah, C is the y-intercept. It's not the x-intercept, it's the y-intercept. It's where the curve intersects y-axis. So if C is positive, so the curve intersects, if the curve intersects y-axis at a point above or in the positive number, that means C is positive. And if it's down, C will be negative. But you see here, C is positive because this point is 0 and C is up. All right? So it's above 0, so it's positive. So now here C is greater than 0, so the answer is C.